Section 2.1 Addition with Variables. Okay, so up until now we've worked with different types of numbers. Whole numbers, integers, rational numbers. But what about unknown numbers? Can we still work with numbers if we don't know what they are? And we kinda can, right? So that's what we're going to talk about. But first, let's kind of define some definitions or some terms that we're going to use a lot of, okay? And so let's go ahead and do that now. First of all, whenever the word term is being used, terms are separated by a plus or a minus. Okay, that's the first thing to keep in mind of. They consist of a number and a variable, or a variable. Okay, it may be just a variable without a number attached to it. Okay, and these are multiplied together. So, for example, 2x to the third power plus 9x. Okay, here we have two terms, right? We have 2x to the third power, we have 9x. Now each term can be broken up. We have a multiplication going on there, right? 2 times x to the third power, and we have 9 times x. But these two are separate terms. Another thing to keep in mind is this is a positive 2, so you can think about there being this understood plus that's in front of it. And this is a positive 9x. That sign goes with the 9x. Okay, it's a positive 9 after all. Okay, so terms, they're separated by a plus or a minus. They're things that are clustered, multiplied together. Okay, when we talk about like terms, we're talking about two terms or more terms that have the exact same variable structure. And what I'm talking about there would be something like 4x squared plus 9x squared, right? These are two terms with the same variables, right? X to the second power. That's different from having something like 4x to the eighth power and 3x to the fourth power. Notice how the variable structures are different, so I can't put those together. Okay, they're not like terms. Okay, so these are like terms, check. These are not like terms. Okay, so terms and like terms. Like terms can be consolidated with addition. Now I'm calling this section addition with variables, but subtraction is lumped in with addition. Okay, they operate pretty similarly. So 8 plus 4, we know how to do 8 plus 4, right? That's 8, tack on 4 more, now we're at 12, right? That wasn't difficult. The same is true when you're combining like terms. So we have 8x plus 4x, well that comes out to be 12x, okay, 12x. You just added 8 plus 4 and you're keeping track. But why? So let's think about that for a second. What 8x represents, let me get rid of this. What 8x represents is 8 x's being added together. Okay, I think that's 8 x's. And 4x represents 4 x's being added together. Let me kind of bring this one down here. X plus x plus x plus x. So how many total x's are there being added together? 12, right? There's 12 x's being added together. Okay, so that's why you just simply add the numbers together like you normally would. You're keeping track of how many x's have been added. Okay, what about 8x squared plus 4x squared? Well, the same thing is true. You could just go back and add a little 2 to all of these and you'll see it's the exact same thing. I'm not actually going to do that. I'm going to take that off. 8x squared plus 4x squared is 12x squared, right? So just like 8 plus 4 is 12, 8x plus 4x is 12x, 8x squared plus 4x squared is 12x squared. Okay, now, notice how we did 8x squared plus 4x squared and we got 12x squared. Okay, what about 12x to the fourth? That's a common question that comes up a lot. Why did I not combine or add up the exponents as well? Okay, so let's talk about that for a second. Let's see. 8x squared plus 4x squared is 12x squared. I'm going to plug a number in and see what I get. Remember, that x is holding the place of a number that I don't know. But whatever I do, if I plug in a number into 8x squared plus 4x squared, whatever I get as a result, I should get in this consolidated version as well. So if I plug in the same number there, these two things should come out to be the same. Okay, so I'm going to plug in 2. I'm also going to do the same thing with x to the fourth power, 12x to the fourth power. Okay, I'm going to substitute in a 2. Say that my unknown x value is 2. Okay, let's hope that whatever I get for this one will come out to be the same for this one and not be the same for this one. Okay, all right, so 8 times 2 times 2, right? That's 8 times 2, which is 16, times 2 is 32, plus 4 times 2 times 2. 4 times 2 is 8, times 2 again is 16. So I have 32 plus 16, which would be 48. So my original expression, if I plug in 2, comes out to be 48. This should be 48 as well, because I'm claiming that these two are the same. So let's plug in 2 and see. 12 times 2 squared, that means 12 times 2 times 2. Okay, well 12 times 2 is 24. 24 times 2 is 48. Okay, so yeah, they're the same. Great. What about 12 times 2 times 2 times 2 times 2, right? That 2 being to the fourth power. I'm actually going to write this one out. Right? 12 times 2 is 24. Times another 2 would be 48. Times 2 times 2. I'm going to multiply those together and get my 4. So this is 48 times 4. And what is that going to be? 192. I don't trust my math on that one. 48 times 4 is 192. Right. Notice that is not the same thing as 48, right? So you can see it here. You can see it here. Yes, 12x squared is the same thing as 8x squared plus 4x squared. Because if I plug in a number, they give me the same thing. This is just a simplified version of that. This has nothing to do with those two. Okay, so they are not the same. Okay, so that was a fun little discussion there. Let's see if we can simplify these real quick. So, remember, since you're adding terms together, you're adding, subtracting terms, the process follows the sign rules as before, right? So, you remember the rules. 8x squared minus 4x squared, that's just 8 minus 4, which would be 4x squared. So 4x squared is my simplified version of 8x squared minus 4x squared. Okay, negative 8x squared plus 4x squared. Okay, we're adding a negative and a positive. I'm ignoring the x's for now. I'm adding a negative and a positive together. Negative 8 plus 4 is negative 4, right? So therefore, my answer here, my simplified expression, is negative 4x squared. Okay? Negative 8x squared minus 4x squared. Okay, I have two negatives now, right? Negative and negative, add them together, keep their sign. So negative 8 minus 4 is negative 12. So my simplified version is negative 12x squared. Okay, so notice they're basically just simplified versions of before, and it's just the same sign rules as before. Okay, what about unlike terms? So here's a good expression. This is an expression that has 4 terms, right? 1, 2, 3, and 4. So we have 4 terms. Okay, so which ones are like terms, right? That's the next thing. Which ones are like terms? Well, 8x squared, negative 4x squared, those are like terms, right? So I'm going to put those two together. 8x squared minus 4x squared is going to be 4x squared, right? They have the same variable structure, so I know those two are alike. I can put them together. 8 minus 4 is 4, so I have 4x squared. We also have this 2x to the third power and this 7x to the third power. Okay, well, they both have x to the third power, so they are like terms. 2 plus 7 is 9, so we have plus 9x to the third power. So 4x squared plus 9x to the third power. Okay, so I simplified it. Now, this is still 2 terms as a result, right? We still have 2 terms, but at least those 2 terms, that's a simpler version of these 4 terms here. Okay. And I think that's about it. So that would be addition with variables.